Hi there, this is Victor here, and welcome to Real Robots Rocks. And today we're going to talk about the Tesla D1 chip, the Dojo, the Exapod, a whole bunch of other acronyms that they mentioned on AI Day. And I think you pretty much know what that is. It's just a big, huge supercomputer, especially designed for training neural nets. But I'm here to really talk about, what's the special thing? What's the big deal about this? I mean, they've been building supercomputers for a long time. I mean, they have supercomputers that can do exaflop for a couple of years now, and some of them can just take a couple of PCs and a whole bunch of networking, and you can make one, right? So what's the big deal? Well, let's take a look at what a conventional supercomputer uses these days. They take something like this, right? And then they plug in a network card, not something like this, but something faster than this, some InfiniBand or some exotic network stuff, and then they'll put some conventional PC, CPU, and then they'll plug in a graphics card maybe, and then they'll put this all in a big room with a whole bunch of power supplies, a lot of cooling, and write some special software to do what they need to do for their supercompute tasks. And that's what a supercomputer is, right? It's just a big conventional computer connected together with networking. So what's the big deal about Exapod? Well, the big deal about this is that they've actually taken this, right? This big board here, right? Networking, high-speed networking, high-speed computing, and some GPU, which is very high speed too, and they shrunk it down to basically one chip. So a chip like that. Okay, so basically they made a smaller, more area efficient supercomputer. Great. That's a big change compared to what everybody else is doing right now, which is just taking some Intel AMD parts and then slapping it on some NVIDIA parts and some Milex parts for InfiniBand, and ta-da, we got a supercomputer. But why? So I think one of the reasons is space. So you're saving a lot of space by doing this. They're saying that you can put together 2 server cabinets together, 10 server cabinets together, and you can make a supercomputer that can do 1 exaflop. Another thing that people don't realize is that because it's so small, you actually use a lot less power. So when you compare the power numbers from the Tesla to some of the top 500 computers out there right now, it consumes quite a bit less power. Right now, of course, they're saying it's an estimated amount of exaflop performance, but in terms of, from a technical engineering point of view, because they'll be able to shrink these components down to a die size, you're going to consume less power, right? Because when you're doing a lot of communication between chips, right, typically, we can only use copper wires for 3 or 4 meters before we have to move to fiber optics to move lots of data, right? So if your computer is the size of a huge building, you're forced to use fiber optics. And fiber optic modules aren't cheap, and they're not power efficient. They consume a lot of power. All the infrastructure, all the cabling takes a lot of time to wire together. But if you're able to shrink all that into a module and get away from all these optic modules, and get away from all these big fat cables that are specially shielded, have special controlled impedances, everything like that, you can really make it a lot smaller and use a lot less power, right? And so it makes it quite a bit easier to integrate this into an existing facility, because putting down a 10,000 kilowatt or 30,000 kilowatt computer and having to deal with all the power, all the heat associated with that, it's a big task. And something that's 1/10, 1/30th power, it's a lot easier to deal with. Not easy, but it's a lot easier to deal with, right? And I think the other thing about this D1 chip that people don't realize is that it pretty much is what is going to drive the Tesla's autonomous driving features, the auto drive. So I think the Tesla chip, the D1 chip, the whole all this idea of the pod, it's a very interesting concept. It's not been tried before, but I think to do this supercomputing efficiently and with budget that is reasonable. I think they're going down the right path, and the fact that they're trying to squeeze everything down to a die, and they're basically saving a lot of headache going forward if they actually make it work. You know, instead of having a lot of components, a lot of the memory, the storage. So yeah, I think the Tesla D1 chip and the exapod and all these pod concepts it's very interesting. And what it allows you to do is that it allows you to collapse everything down to a very small space. And with that, you don't have to have tons of fiber optic modules. You don't have to have everything you pretty much need is all in one die, right? You don't have to worry about the memory. You don't have to worry about network switches. You don't have to worry about a lot of other things. Right? The compute's all in one area, and so you got a lot of power savings. You got a lot of size savings. You got a lot of infrastructure savings. And in fact, you can actually put a lot more of these, exapods into one computer data center. And so I think that's what's important about this design. I mean, if you look at typical supercomputer, I mean, a lot of these are specially built rooms with specially built cooling, with specially built power. Everything's so special that it's really hard to have this put inside a corporate environment. But I think something that's a little more thermal friendly and electrical friendly, it definitely is going down the road where it's something that not everybody can put one down, but it's something that at least you don't need to have a dedicated team to plan this out for 10 years, right? So yeah, I mean that's pretty much what I would really want to talk about the Tesla chip. I mean, it's a very cool thing, and yeah, sure, a lot of critics are bashing it, but I think there's a lot of interesting things and concepts I've been trying, and I think that's what this industry really needs. I mean, you can't just keep doing the same thing over and over again. I think you need to try some new concepts, and this definitely is a new concept. Anyway, have a good day, and hope to see you next time. Bye.